and they call it algebra. Go over again to the complex because it's extremely important. It's extremely important. However, so far I want to explain the most important idea about complex number. Okay. So we have the real number, the classical real number. Okay, everyone know. Okay, we can represent in this line. 0 in the middle, infinity positive, infinity negative. And the right part 1, 2, 3, 4 positive. Yeah, and the left negative. Okay, this is a classic. However, we have another number. For suppose we need to compute a square root, negative 25. Okay, I have no idea, but I know that square roots is a number que multiplied by itself. Repetition, give me the number inside the radical, que es negative 25. Entonces, well, I believe que 5, because 5 times 5, pero 5 times 5 is 25, no negative 25. Well, entonces I select negative 5, but negative 5 times negative 5, negative positive is 25. So never, you don't get the answer of the square root negative 25 on the all real number line. No, because remember, I put intentionally one box and one box. Entonces es totally illegal to put inside the box different number. So Anuela say, well, what about 5 and negative 5? Well, 5 and negative 5, of course, is negative 25, but according to the definition, square root, any number is equal another number times another number, and this number should be the same, multiplied by itself. Give me this number. So what is the conclusion? Well, the conclusion is, okay, the conclusion is no real solution. No real solution. Efficiency que try to solve any problem always create by definition que square root negative 1 is I. Okay, entonces we have now a new numbers que contain I. Because we solving this problem, I come back at the beginning, square root negative 25, you break it down like a square root positive 25 times square root negative 1. And this is 5, so pure is 5. And the answer is 5. And this new number que contain I is called imaginary. This is history, because the word imaginary look like a ghost, but actually it's no ghost. Imaginary is a physical number, it's a logical number, however belong to another dimension. O sea, it's no in this line, pero it's in another line, que es the imaginary line. And the combination, and the most common, frequently, often, we working is the combination real and imaginary together. Suppose 3 in which we have one complex number. This is a complex. And what is a complex number? Well, a complex number is a combination real number. This is the real part. And the I part is the imaginary part. And for example, we have one of the classical real number that we studied at the beginning, 345. This is example of the pure real number, because we have no I, We can interpret it like that. This belongs to the complex field? Yes, because it's 3 plus 0i. So the imaginary part is missing, is 0. And we have another number, que is, for example, 3, 4, 5, pero contain I. This is pure imaginary. Pure imaginary. It is my internet. Is it my internet? What is? Oh, Professor Internet. Professor Internet is strong. You don't see something?
I hear you well, Professor.
Okay, I know. The pure imaginary is the number que contain only I and have no, so we can interpretation like it's 0 plus 3i, 0 plus 4i, 0 plus 3i. So we have, and of course the complex is the combination, is a number que contain pure real and pure imaginary. It's okay? One more thing that you need to know about the complex number. Well, let me try to explain the power of I. Power of I. Power of I. Okay, power of I. So I want to investigate what happened, what's going on when you raise to the any power. I to the 1 power, I to the 2nd power, I to the 3rd power, I to the 4th power, and so on, I to the any power. Well, I to the 1 power is obvious que I. I by definition was square root negative 1. This is the, you know, some people confuse it with this, but this I is a symbolic way to express a square root negative 1 because it's too tedious to write 5 square root negative 1. Well, it's much better to write 5i. Everyone in the world knows that when you have a number that contains I, it's square root negative 1. Okay, so what about I squared? Look at that. I squared is I times I. And who is I? It's square root negative 1. And square root negative 1. And square root negative 1 is square root negative 1. So you put together is square root 1, que es 1. It's negative. Sorry. Okay. No, not like that. This is wrong. It's square root negative 1 is square. And you know que square root and square power cancel out each other, and the answer is negative 1. Okay, entonces, unbelievable but true. I square is equal negative 1. So I square is not imaginary. I square is real. I square belongs to this line here in this position. This is negative I, but it's equivalent to I square. So not always when you have I is imaginary. You can replace. When you see in one operation I square, immediately everyone replace I square for negative 1. Okay, I cubic is I times I times I, 3i. But I know that 2i together is negative 1. So the answer is negative 1. Therefore, let me summarize here. I is I. It's imaginary. I square is negative 1. Es real. I cubic, I discover que es negative I. Es imaginary again. Y I to the 4th power is I times I times I times I for I. Therefore, we have I square and I square together is negative 1. I square and I square is negative 1. And negative 1 times negative 1 is positive 1. Wow. I to the 4th power is positive 1. Again, is real. And this situation is repeated 4 by 4. Okay, it's alternating. Imaginary real, imaginary real, imaginary real. And this part is repeated 4 by 4 in this sense. Let me show you. I to the 5th power, I to the 6th power, I to the 7th power, I to the 8th power. Have some internet connection. I didn't understand the topic. Well, okay. Everyone follow me except Noela?
It's recorded.
English say this is a recorder. Immediately I send when the class is over the video, and you can see. Okay, thank you. Okay, I to the fifth power. Let me focus. To the fifth power. To the fifth power, in my mind, is I can break it down like I to the 4 and I to the 1. Because 4 plus 1 is 5. It's the rule of the exponent. Y I know que I to the 4 es 1. Y 1 es invisible. Entonces es I. Wow. Entonces repetition. Look. This I is this I. I can prove, but I don't want to do, que es repetition the same. Suppose I to the 9, 10, 11, and 12 is exactly the same. Repetition this pattern, 4 by 4. I, negative 1, negative I, and 1. Okay, professor, I understand that. However, they are a formula to find I to the any power? Yes, they are a formula. Not exactly formula, sino procedure to find. Suppose I to the 27. I need to continue this stupid sequence? No. No. Because I take advantage that every multiple of 4, the I to the 4 power, to the 8 power, to the 12 power, and so on, 16, no? 20, 24, and so on, is 1. And 1 is invisible factor, right? So I try, okay, listen to me. This is a shortcut to do fast in 1 second. You take 27, get the exponent, you divide by 4 by hand. It's obvious que 6, right? Because 6 times 24 is 24. Subtraction is 3.
Y by 4.
Divided by 4, yeah, divided by 4. Why divided by 4? What is the reason? Because this part is repeated 4 by 4. Bam. Entonces, suppose que this is the group 0. I call that. This is the group 1. This is the group 2, and so on, no? Entonces, this is by group 4 by 4. So you connect it. So you divide by 4 and only to determine in what group belong, and also well the position inside the group. So you divide by 4. It's clear. It's understandable what the reason I divided by 4, right? 1, 2, 3, and 4 row we have in this pattern. Divided by 4. Entonces es in the group 6. And the remainder is 3. And this is equivalent to say I cubic. So I delete that part because it's I27 in my mind. It's like a I24 times I to the third power. But 24 is exact multiple of 4. And this is equal 1. So I cubic. And who is I cubic? Look at that. In my first column in group 0 is negative I. And the answer is negative I. Okay. Curiosity. See, curiosity. Let me try to continue. Suppose I am doing like a stupid guy. We continue, for example, here. Group 3, group 4, group 5, and group 6, que es exactly the group que belong to 27, group 6. Well, this is I to the 16, no? This is 12, 16, this is 20, this is 24, and this is 28. Entonces, en this group, I focus in this group. I suppose que es I27, 27, 26, and 25. 25. And this is I, this is negative 1, and this is negative I. And this is my answer, negative I. Okay, so what is the shortcut to do in 1 second? You divide it by 4. By hand, no calculator. Because in the calculator you get decimals. No. And you have two numbers, quotient and remainder. And the remainder is the information that we need. The quotient is not important because I don't care in what group belong 27. Basically, I care in what position. Entonces, es in the third position y en the third position es negative. Clear, or you need another example? Clear, or you need another example?
Professor, to be honest, I didn't understand like the topic in general. I'm lost.
Okay. I want to repeat again with another example. Suppose you compare I to the 42. 42. Putting off the microphone, please. Well, it's excellent.
It's not.
Is your no microphone? Oh, let me check it. Okay, good, no problem. Suppose I to the 42. You divide 42 divided by 4. Ok, entonces 1 es, bueno, es 10. Es 10 because 10 times es 40.
40 remainder 2.
Eso. And you take the remainder. The second power is in the position 2. Entonces the answer is negative, que es real. It's clear now? It's clear?
Yes, Professor.
It's easy. No, don't try to see more beyond this because it's super elementary. Of course, in college algebra, I complicate a little bit your life using positive exponent, negative exponent, but no. We are not in college algebra. So you understand the idea? What is the conclusion? Que we have two kinds of number. We have real number, the traditional, que all my life working with the real number, but we have a new number that is called imaginary. And the combination both form the complex number. Now the complex field, I suppose, is a big set. It's a complex. This is a symbolic way to indicate complex. And the real field is a subset inside. So any real number is also complex, but the problem is that these real have no imaginary part. The rest is imaginary part. Imaginary is the complex. Okay? Okay. Now let's focus in the solution of the quadratic equation. So far, quadratic equation. So far, we are solving quadratic equation. Actually, yes, we are doing. But we are doing in one weak way, que es by factoring. Because sometimes I don't see very well what is the combination, what is the key to open the door of the factorization. It's not clear. And sometimes it's impossible. Why is impossible? Because the quadratic equation, si you are doing graphic, well, quadratic equation is like that. Ax equal to 0. It's important to understand B and C, A, B, and C are in general real numbers. And of course, A no 0. This is the most important because si A is 0, A is missing. And si A is missing, entonces this equation is not quadratic. O sea, the clue que give me information que this equation is quadratic is that part. If that part do not exist, entonces no quadratic, es linear equation. Okay, entonces we are talking about linear. No expect que in any problem, the equation, because this is a standard form. How you know? How do you know it's a standard form? Because right hand side is 0. Right hand side must be 0. And you organize in descending order of the degree. Degree 2, degree 1, and degree 0. Because any number or variable raised to the 0 power is 1, no? And this power 1 is invisible. Okay, so now the first job that you should do in order to solve quadratic equation is putting a standard. And by the way, clear fractions. And by the way, clear decimal. How you create the fraction, you know, multiply by least common denominator. When you multiply any equation by the least common denominator, disappear the fraction. This is classical, you know. And when you have decimal, you multiply by 10, by 100 or 1,000, depending the decimal point you have, and you delete that. However, the graph of the quadratic equation look like a parabola, like that. Parabola is no line. Parabola is something like that. I promise que in college algebra we study in detail the most important characteristic of the parabola. So we have three possibilities. The parabola cross the x-axis in 2 points, and we have two solutions. Because actually, the solution for this equation is the x-intercept of the parabola. Okay, two solutions. But sometimes the parabola touch at 1 point. You have only one solution. And sometimes happens that the parabola never cross the x-axis. In this case, we have no solution or no real solution. But we have solution, yes, always we have solution. The polynomial equation always have solution. And in this case, the solution are complex. Okay, it's complex. Complex solution. So we have three possibility, guys, that we study today. Two real solutions, two non-repeated real solution. Real solution. Okay. One is like a, because you suppose always that the solution for the quadratic equation is two solutions, but in this case it's a coincidence that the solution is 2, 2. Therefore, we have only one solution. So actually, you can write, tomorrow, professor, the solution is 2 and 2. Okay, I understand. But when it's repeated, you write like that. Only 1, 2, because it's the same guy. Or the solution are complex. When this situation happens, it's complex, and the solution coming by pair of conjugate. Suppose 3 plus 2i, comma, 3 minus 2i. They are conjugate. Conjugate. Always. You have, for example, 3 plus 2i, and another solution is 3 minus 5i. No, it's impossible. It's exactly the same as a family, but it's a conjugate. So the imaginary part, one is positive, another is negative. Some people prefer write like that. 3 plus or minus 12. Always happen that situation. Okay? This is the introduction. Now, I want to explain now in detail the formula. What is the formula? What is the formula that we are using for solving the quadratic equation? Well. So first of all, before the formula, I want to explain one technique that is completely square. Completely square. What mean that? Well, completely square is one technique. Suppose that we have this equation, x squared plus 4x plus 5 equal to 0. We can do by factorization. Okay. The factorization is 5 and 1, no? X, 5 and 1. Because 5 times 1 is 5. If 5 plus 1 is or minus. No, it's impossible. Because it's the same sign, but it's plus plus is 5 plus 1 is 6, not 4. So it's impossible. This is impossible. We have a formula. But I want to explain Nuela, the formula. Wait a second. So by factorization was impossible. I tried to complete the square. What is the idea for the completed square? Well, the completed square idea is, let me show you. Let's try to find a perfect square trinomial, a perfect square trinomial associated with that. So I know that x squared plus 4x would be perfect square si es 4, not 5. You remember that, right? Okay, let me repeat the idea. One trinomial is perfect square when there's a multiplication. This time is L, que by the way is like a plus b squared, que by the way is ab squared. And the proof is perfect square. You find the square root, this is a. You find the square root, this is b. Multiply each other, ab, and extra 2, and you get the middle term. It's perfect square. In this case, I'm checking si it's perfect square or not. Square root of this guy is x. Square root of this guy is 2. And 2 times x times extra 2 is 4x. This is perfect square. Okay. One mnemonic device to remember very well this. The formula is, okay, I have no idea. Professor, where come from this 4? Because you know by memory. No, the formula is, look, the formula is b divided by 2. What is the reason it's 2? Because remember, we have extra 2, and do you remove this 2? Divided by 2 and square. In our specific example, b, the coefficient is 1 here, b is 4, and c is 5 in our equation. Do you take b, get 4. You take b, get 4. 4 divided by 2 is 2, no? A square is 4. Oh. This is the answer, look. This is the magic number. So the magic number is 4 because I apply the formula b over 2 square. B in our specific example is 4 divided by 2 is 2, and 2 squared is 4. That is a reason que I introduce artificially this 4, que es the number que complete the square. Entonces, bueno, okay, I understand that. However, what's happened with the 5? Well, 5 is, you break it down mentally, like a 4 and 5. 4 and 1. In my opinion, to do in the super systematic way, look, in the super systematic way is, look, I copy, I bring down x squared. Yeah. Okay, sorry. X squared plus 4x plus a box, and inside the box, I put the magic number que complete the square. Entonces I move 5 to the other side, like a minus 5 plus the box, because I introduce artificially this number in both sides. That completes the square gets 4. Okay. Now, we almost finish. After that, we almost finish. Okay. I know que this trinomial is perfect square. And the factorization is x plus 2 square. Where come from this x? Square root this. Where come from this 2? Square root 4. In the right hand side, we have negative 1. Okay, in this moment, I apply one thing, it's called square root method. And the square root method is apply square root both sides. Why? Because I want to cancel out this power 2 and the square root is just x plus 2. And this is I. And this is I. By definition, this is I. But you always put plus and minus, double sign. Because I consider a square root, any number, have double sign. Okay. Finally, I solve for x, que is my goal. I move 2 to the other side, minus 2, plus or minus. Conclusion. What is the conclusion? Well, this equation, the original equation, this horrible equation, It's relatively easy. Contain two solutions, and the solutions are minus 2 plus I, comma, minus 2 minus I. Two complex solutions. Two complex solutions. Okay, I suppose que the parabola que describe this quadratic equation never cross the x-axis and the 1 point. Therefore, the solutions are complex. Okay, this looks like complicated, I know. However, we have the formula, que es the formula que Nuela want. Nuela press me to the formula. What is the quadratic formula? Quadratic formula. Okay, this is fantastic, guys. This is fantastic. Everyone doing that way. Nobody doing in the complete square, no. And quadratic formula is like that. Minus b plus or minus, exactly like that, plus or minus square root b squared minus 4ac divided whole thing by 2a. This is my quadratic formula. Allow me for solving any quadratic equation. The equation that we have in the handout and the equation that we solved before. So what is the procedure? The procedure is step one. Suppose I come back again to the same stupid example. You have this equation. You in the step one determine who is A, B, and C. Okay, remember A is 1, because the coefficient here is 1, B is 4, and C is 5. And just plugging into the formula. Into the formula. Okay, minus, the formula have a minus b, pero b is 4. Plus or minus, square root, 4 squared, because b is 4, minus 4 multiplication by 1 multiplication by 5, divided by 2 times 1. Don't do any operation. Only plugging into the formula. Now you focus according to the order of operation. You focus in the operation inside the radical. That's the first thing you square 16 minus something. 4 times 1 is 4 times 5 is 20. Subtraction is negative 4. After you compute the square root negative 4. I know que square root negative 4 is imaginary. Entonces es equivalent to I, square root 4, que es 2. Es 2i. Okay, 2i is the answer of this expression inside no, the total radical expression. And we have minus 4 plus or minus 2i divided by 2. 2i divided by 2. And leave it like that. Well, no. You split this common denominator in negative 4 divided by 2 is negative 2 plus or minus, and 2 divided by 2 is I. It's 1, no? 2 divided by 2 is 1, pero you get exactly the same answer in 2 seconds. And the advantage that we can use in calculator. No necessary sophisticate factorization, no necessary sophisticate complete square. Okay, entonces basically, well, entonces you apply anytime the quadratic formula. No. There are some particular example que is better using another technique. So basically, this is the thing that we study now. We study different technique for solving the quadratic equation, pero in this case, I propose you go back to the package.
Yes, sir. Can you
Go ahead. Say again?
I just want to take a picture, Professor.
Okay. Picture. Quadratic equation, quadratic formula.
Thank you.
Okay, let's move on to the package. I remember that we are doing until 6, now 7. 7 problems, say 7. 7 is 5c squared minus 500 equal to 0. Okay, my question is, this is a quadratic equation, yes or no? This is a quadratic equation, yes or no? Of course, yes. The answer is yes. How do you know? What is the glue that give me information against quadratic? These two.
The A.
Okay. When you have in one equation, one exponent 2, that is quadratic equation. So suppose you have this equation, 5c minus 500 equals 0. This is quadratic equation or linear equation? Look at the difference. This is 2 exponent, this is no 1 exponent, I suppose. This is linear. And the linear you solve it like a rush. The first day we are doing that. Move 500 divided by 5, end the story. No, but now we're solving quadratic. And this quadratic we can solve it using the factorization, maybe yes, or we can use the quadratic formula that we studied before, maybe yes, but it's very, very useless. So there another one shortcut that you apply when the B is 0, because look, A is 5. It's obvious A is 5. Get the coefficient here in front of the c squared, get the variable. But B is 0. B is missing. And c is negative 500. And when the B is 0, I highly recommend doing by this way. Okay, I want to explain now. Okay, the name of this method is called square root method. The square root method. What should I do? Well, you try to manipulate the equation similar to the linear equation. What means to the linear equation? Well, you solve for c squared. I move 500 to the right, divided by 5, 100. In this crucial moment, this is the most important moment, you apply square root. Okay, the part that gives it this name, square root method. I know the square power and square root cancel out each other, and square root 110 and plus or minus. And the answer is solution set plus or minus 10 or 10 and negative 10, no? They're the same. This is a fantastic way. But this fantastic way is applied when the B is 0. Okay? Okay. We can do it another way. Yeah, we can do it. In factorization, yes, we can. Suppose we come back at the beginning. 5c squared minus 500 equals 0. Yeah, I focus it in the left-hand side. What is the GCF? F5. Entonces, c squared minus 100 equal to 0. And this 5 is completely useless because you divide by 5 both sides. Yes, c squared minus 100 equal to 0 because 0 divided by 5 is 0. Now you apply a difference of a square. Open to parenthesis, zz, 10 because the square root 110 plus or minus. You separate in two linear equations. The first one is the second is, it's obvious que c is negative 10 and c is positive. But it's too long. It's too long. So in my opinion, the shortcut to do super fast is the square root. What is the disadvantage of the square root? Okay, you need to remember in the last moment, when you apply the square root, you put double sign, plus and minus. It's the only detail, sophisticated detail that you have to remember. Any question? Let's move into number 8. Number
Professor,
A. Go ahead. You want to take a picture again?
yes. Thank you.
Suppose number 8 is x squared plus 5 equal 69. Well, again, a quadratic equation. Again, it's incomplete quadratic equation because b is missing. Okay, who is A? A is 1. Who is C? Well, I have no idea. Maybe it's 64, no? Because you move 5 to the other side. 69 minus 5 is 64. Now apply square root both sides. X alone is equal plus or minus 8. And it's the answer. Okay, do you understand very well what is the reason I put dollar sign or no? Suppose I am doing by factorization, x squared minus 64 equal to 0. When you break it down, this is a and negative a. That is the reason that we have dollar sign. Another reason that we have dollar sign, actually, square root x squared, you suppose que es x. It actually is not x, it's actual value x. Actual value x equal 8 is two solutions, a and negative a. But no, don't worry for this and for that. Automatically, everyone in the world consider that the square root of one number give me two solutions. The reason is clear. 8 times a is 64. And negative a is 64. Positive. Therefore, when you compute the square root of any number, we have two solutions, one positive and one negative. That's it. One more example, number 9. Of the specific square root. Noela, you have to take a picture?
No, Professor.
No, okay. Number 9. Number 9 is 2n squared minus 56 equal to 0. Okay, what should I do? Well, again, identification, quadratic equation, B is missing. Entonces, in my opinion, the best way to solve that is the square root. Because I working as a linear, you solve for n squared. 2n squared is equal to 56 divided by 2, both sides. N squared is equal to 28. Apply square root both sides. N alone is equal plus or minus square root 28. Leave it like that? No. I know that 28 is no perfect square, like another example, but 28 is 214, 27. You say you discover a couple of 2 here that represent 1, 2 outside, and actually the elegant final answer is plus or minus 2 radical 7. End the story. Like the option A. Any question? Find the non-real complex solution. Okay. It's easy, eh? You remember this in the high school, no?
A little bit.
Yeah, a little bit. So now let's continue, but in this case 10, 11, and so on. We are solving not by square root, we solving by the formula, quadratic formula, because there's more efficiency doing that way. Look, suppose x squared minus 10x plus 34 equal to 0. Okay, this equation is already expressed in standard. And you clearly can identification A is 1, B is negative 10, and C is 34. I copy my formula. When you practice a little bit, you memorize the formula. One typical mistake I saw that some students write the formula is Okay, the students, for example, another student divide everything by 2a here. This is wrong. This is totally wrong. You divide a whole thing by 2a. Whole thing, long line, by 2a. And plugging in. Be careful with the plugging in. Be careful with the sign. The formula have a minus here. And b is minus. So we have double minus. When you plug it in, you have actually minus 10. Entonces doble minus becomes positive, ¿no? 10. Plus or minus, square root. Negative 10 squared, que es b squared, minus 4. Multiplication by a, que es 1. Multiplication by c, que es 34. Everything divided by 2 times 1, que es just 2. Now, you don't worry, you focus in the operation inside the radical, que is the first que you should do here. And of course, using calculator, no? In this moment, I have the calculator in my hand. Okay. And negative 10 squared is obvious que es 100, yes or no? It doesn't matter que es positive or negative, it's 100. Now you put in the calculator 4 times 1, que bueno, es 4 times 34, que es 136, minus 136. Now subtraction is minus 36. And you find the square root. This square root is this square root. So I did the operation inside first. Now this is a moment to find square root 36. Okay. Immediately you see inside the square root, negative number is imaginary, I. I times what? The square root positive 36. And it's 6i. And the answer for that part is 6i. And so far we have 10 plus or minus 6i divided by 2. And leave it like that? Of course, no. You split this common denominator, 10 over 2, plus or minus 6i over 2, and 10 over 2 is 5, plus or minus 3i. Final answer. Elegant answer. Is the option A. Do you understand the procedure? Nice.
No,
yeah. It's super elegant.
No, because I don't understand why it's I.
Look, when I come, okay. Let me take advantage of this moment to explain additional thing. The behavior of the solutions, si es real or es imaginary or es complex, whatever, depending of the expression inside the radical, que es the expression que I put enclosed in the blue color, right? And this expression is b squared minus 4ac. Okay, it's this expression. And this guy is important. Some people call in the book discriminant, capital D, discriminant. Because according to the sign, give me information. When it's discriminant, it's a positive number. We have two real solutions. Two non-repeated, non-repeated real solution. When the D is 0, one real solution. And when the D is negative, like this example is complex solution. In this case, Noela, I discovered que es negative 36. The reason que es I is because when you compare the square root negative 36, remember, any negative number inside the radical, no real solution. How we compute that? Well, you compute the square root positive 36, I know que es real, and you additional 1i, because the square root negative 1 is I. This is 6i. Clear?
Yes, clear.
Entonces, one shortcut to compute fast is compute the discriminant first. Well, actually, it's the first thing you should do is compute the number inside. See, the answer is positive. We expect two solutions. Real. See, the answer is 0, 1, no. We have only one. And see, the answer is negative. We have complex. Okay? So today we practice this, and we continue next time practice more. Example. This is important. Quadratic equation. You need to training in this. Super good. Okay. This 11 now. 11 now. 11 is x squared plus 4x plus 29 equal to 0. Oh, okay, nice. I like that because it's already expressed in standard. Nice. I can determine quickly que A, B, C, A is 1, B is 4 positive, and C is 29 positive. I'm using my formula again. I copy the formula because I pretend you memorize that formula. Not today, throughout the chapter, no? Entonces, substitution, B is 4, minus 4, remember the formula contains minus, but B is positive, so positive and negative is negative, plus or minus square root, 4 squared, because B is 4, minus 4, multiplication by 1, multiplication by 6 is 29, divided by 2 times 1. Okay, I focus on the expression inside. Okay? By the way, this is the discriminant. This is the discriminant. It's obvious it's negative, no? Because this is 16. This is 16. Minus something, que I suppose que this something is bigger than 16. It's 29 times 4. 29 times 4 is 116. Wow. 116. So when you subtract it, it's negative 100, no? And when you compute the square root, negative 100 is I. Remember, when you see inside the radical negative quantity, immediately you see about the I. And the square root 100 is 10. So actually it's I times 10, or much better is 10I. You put a number in the front. So far we have minus 4 plus or minus 10I divided by 2. And you split the common denominator, this is minus 2 plus or minus 5. Final answer. You see how the solution when it's complex is coming by pair of conjugate. Actually it's minus 2 plus 5I and minus 2 minus 5. Like the option 8. Again.
Professor,
Go ahead.
I have a question. When we have like the number in the radical, that means we to put the I, right? That is not a...
Yeah. Absolutely. O sea, Nuela, the fantastic formula is square root negative any number is equal I times square root the same number, pero positive. Okay? Keep in mind that formula. And that's it. Okay? You don't know at the beginning. You compute the expression inside the radical, the discriminant, and you suddenly obtain negative 100. Entonces negative 100 entonces es imaginario. And together, imaginary and complex, and real is complex. Let's move into the number 12. Number 12. Number 12 is x squared plus x plus 5 equals 0. Again, quadratic equation. Again, standard form. Nice. I like that. Determine ABC. In our specific problem is 1, 1, and 5.
And 5.
I'm plugging it into the formula. I love you, that formula. Entonces, what is the advantage and disadvantage? The formula is a systematic way to go directly to the answer. Directly. No, just plugging in. And when you have a good calculator, you have no problem. But it's too long sometimes. However, the factorization is short, but it's weak. Because, for example, in this example que es complex, or another example que es irrational, it's crazy or impossible doing by factorization. Okay? Well, entonces negative 1. So you put the long line of the division, b es 1, entonces negative 1 plus or minus square root 1 square minus 4 multiplication by 1 que es a by 5 que es c divided by 2 times 1. Okay, I make a zoom because I want to see the expression inside the radical, que es the discriminant. 1 square, es 1. And this is 20. And subtraction is negative 19. Entonces, when you try to find square root negative 19, well, you have I, because it's negative. 19 is a prime number, so we can now break it down. We can know simplification more and leave it like that. Okay, now, what is my final answer? My final answer is the real part. The real part is negative 1 plus and minus I radical 19 divided by 2 times 1 que es 2. In this case, we cannot. Well, we can, but yeah. In this case, it's a complex solution. It's a complex solution. So the complex solution, what is the format for the complex solution? The format is one number A plus or minus IB. In this example, A is 2, is negative 2, and B is 5. Entonces, in this case, not clear. Entonces, I propose you always, this is like a standard form to express the complex number. You split this common denominator. You have negative 1/2 plus or minus. You put an I in the front. And this is radical 19 over 2. Okay, this is equivalent, of course. Everyone understands it's the same thing, but it's more elegant. So when you have complex and you have fraction, you separate the fraction, the part is for the real part, and the part is for... be careful because these two is completely outside the radical. Actually, it's radical 19 divided by 2. EI in the front, and plus or minus. And negative 1/2 is the real part. Real part, imaginary part. On Alex, we need to represent... Yeah. Alex Piggy. And remember, guys, any question that you are doing well, yeah, it's great wrong, you let me know. I fix it, right? I go inside your account. I understand that you are doing well, pero Alex Piggy. Now I fix the grade. This is 12. So you feel a little bit comfortable or no? What option you consider is correct? Well, I don't do that. In the option, don't split the common denominator like that. Okay. So I suppose que es the option B, ¿no? O option 8. A ver. No. Es obvio que 6. ¿No? A ver, sí, es obvio que 6. Because B, no, B is wrong, completely wrong. O sea, never. You leave it like that. Negative 1 plus or minus square root negative 19 divided by 2. Because this is a complete job. So you need to continue working. Because you suppose you need to know that when the square root of a negative number is imaginary, you put I. Okay? So it's the option A. But option A, they write like that. Okay. You know, there are different styles of the teacher. This is the just only cosmetic part of the process. You split or no the common denominator. Okay. 13 now. 13 is 5 x squared minus 5x plus 7 equals 0. Okay, again, quadratic equation. quadratic equation expressed in standard form, nice. Identification of the AFI, B is negative 5, and C is 7. Plugging it into the formula. Minus B plus or minus square root B squared minus 4AC divided by 2A. Minus 5. Double minus. Minus of the formula and minus of the value. Become positive. Inside the square root, we have a negative 5 squared. Okay, you know, when you square any negative number, become positive. That's 25. Minus 4 times 5 times 7. Divided by 2 times 5. Is 8. Okay. Make a zoom to see the computation in detail. I focus in the expression inside. Okay, by the way, this is the discriminant. Give me the behavior of the root. Si es real to real, si es one real, or complex. It's 25. Positive, of course. Minus, now 20. 140, I guess so, no? 20, let me see. 20 times 7, yeah. 140, 140.
115?
115. No, it's 4 times 5 times
No,
7.
sorry.
It's 140. I'm doing okay or no?
Yes, 140.
Minus 25 is 150. Negative 150. And square root 115 negative is I square root 115. And 115, I have no idea. It's not divisible by 3. Remember, how do you know it's divisible by 3? You adding 1 plus 1 plus 5. It's 7, no? And see, this number belongs to the 3 table multiplication. Entonces, pero cuando el number ending in 5 is divisible by 5, when you divide by 5, it's 23. Yeah, by 5, yes. And by 5, what the clue recognize that one number is divisible by 5. When the last digit ending in 5 or 0 is divisible by 5. Ending is 5 or 0. Ending in 5 or 0. But unfortunately, 115 contains only 2 factors, okay, 5 and 23, and both are prime. We have no couple to simplification and leave it like that. And leave it like that. Therefore, the answer is then 5. Plus or minus I square root 115 divided by 10. You can write like that, or you can write like that. 5 over 10 plus or minus I radical 115 divided by 10. And this is 1/2 plus or minus I radical 115 over 10. This answer is correct. This answer is also correct. Well, this no, but this is also correct. Que es the way que they want. They want, que es the option, the option B, no? I suppose it be. Any question, guys? Now 14, 15, 16, 17, and 18. We continue doing the quadratic formula. Suppose 14. You understand now, no? Okay, perfect. But don't worry. Remember, this is the regular package. It's too short. However, we have the review package after that, no? Okay, it's not short. Okay, let me see 14. 14 is 2n squared equal minus 10m minus 1. Oh, this problem bring me a new complication. The new complication is que this equation is not already expressed in standard. You move everything to the left because I know the right hand side must be 0. And this is my equation que I start selection ABC, ABC, S2, S10 y S1. Typical mistake que I saw every day. Some students don't believe this, no. Y say, bueno, A es 2, professor, I saw it. B is negative 10, and C is negative 1. This is wrong. This is wrong. So first of all, you need to express any standard, and after that, you recognize who is ABC. Minus B plus or minus square root B squared minus 4AC. You have to practice, of course. Alex is waiting for you. But no, when you finish the test 4. I know that you are focusing on the test 4. Okay, now minus B is minus 10. Minus 10, minus 10, minus 10, plus or minus square root 10 squared, que es 100, I suppose, minus 4, multiplication by 2, multiplication by 1. Divide the whole thing by 2 times 2. Because my formula has a 2, and A is 2. So both are 2, 2 times 2 is 4. I do it that way. However, one fantastic way, in my opinion, is you put 4 directly and 10 squared 100 directly, no? Pero it's okay, it's okay. I respect anyway. Entonces, let me focus in the discriminant, the expression inside. No. This is 100 minus 8, que es 92, ¿no? Pero 92 positive, therefore, it's a square root of 92 positive, entonces no I anymore. It's I when it's negative. No, pero no. In this case, it's positive, therefore, it's real solution. And 92, well, 92 is divisible by 2. Okay, suppose que es 48, no? Let me check it just in case in the calculator. 92 divided by 2 is 46. Not 48, coño. 46. 46. And 46 is divisible by 2, que es 23. And 23 is a prime number. We cannot continue breaking down, and you discover at least one couple of 2 que represent 1, 2 outside the radical. Entonces, actually, entonces 2 radical 23, something like that, right? And this 2 is this 2. And this 23 stay inside the radical. Entonces, minus 10 plus or minus 2, 4. In this case, yes. I highly recommend that you split this common denominator or mentally another shortcut to do super fast. You divide by 2, by 2, by 2, and by 2. Or of course, outside the radical. Entonces, negative 5 plus or minus 2 divided by 2 is 1, es radical 23 divided by 2. See, you don't understand very well that way. Okay. You are doing a different way. Look at that. Minus 10 plus or minus 2 radical 4. I can see that in the top part, the GCF is 2. Because in between 2 and 10 is 2. You factorization 2, we have a negative 5 plus or minus radical 23 over 4. And now you are ready to simplification this. Divided by 2, 1, divided by 2 is 2. And we get exactly the same answer like that. Guys, either way, you create your own shortcut to do fast, the way you prefer. This is the beauty of the algebra. 14. Any question about 14? Wait. I need to select what's the answer. The answer is... What's the answer? What is the answer? The answer is C, no? Es C. The answer is C, yeah. Es C. The answer is C. Okay, good. Answer is C. Okay, 15. 1, 5. 115 is, wow, what the hell is that? C squared over 3 is equal C over 2 plus 5 over 6. Wow, this is a crazy equation. Pero this is quadratic equation, yes or no? Yes or no? It's quadratic equation, yes or no?
Yes, Professor.
Absolutely. What is the glue that give me information that's quadratic? Exponent 2. Exponent 1, linear. Exponent 2, quadratic. Is already in standard? No. Of course no. Because the standard, remember, it's something like that. It's A, bueno, C is the variable, BC plus C equal to 0. So you need to manipulate, multiply by C. Exactly. Noela proposed me, first of all, remove the fraction. And the least common denominator is obviously 6. So the least common denominator between 3, 2, and 6 is 6. And you multiply, complete the equation by 6. Entonces 6 divided by 3 is 2c squared is equal 3z plus 5. Plus 5. Ready? No. No, because it's not expressing it. So the thing I did was remove the fraction. Always. Highly recommend that. Nobody can work in quadratic formula using fraction. This is crazy. We can, yes, we can, but it's crazy. However, express it in standard. 2z squared minus 3z minus 5 equal to 0. And you determine que A is 2, B is negative 3, and C is negative 5. Guys, the important thing, because the student mechanical are doing the job, but don't understand very well. This equation gets given at the beginning, que is completely disorganized and contain fraction. After the manipulation, que is this, is equivalent 100%. It's the same equation, but in a more elegant way, understandable to apply the quadratic formula. Minus b plus or minus square root b squared minus 40c divided by 2. Entonces 3 positive, double minus again, the minus of the formula and the minus of the b value. Plus or minus square root minus 3 squared minus 4 multiplication by 2 is a multiplication by c is negative 5. Be careful with the sign 2 times 2. Be careful in the sign, because in this part, when I try to compute that part, look, it's obvious that this is 9, because I know that negative number raised to the second power is over. But here we have 2 negative, become positive. Be careful. And this is 8, 5, 40, 49. And the square root of 49 is real, it's 7. Easy. Therefore, we have so far, we have 3 plus or minus 7 divided by 4. So in this moment, I like so much this organization. You separate in 2 pieces. 3 plus 7 over 4 and 3 minus 7 over 4. Because this double sign is at least for me, hard to manipulate. This is 10 over 4. We can reduce it with, of course, a 5 over 2 divided by 2. And this is my first solution. And this is 3 minus 7, negative 4. Divided by positive 4 is negative 1. So we have 2 solutions. The solution is solution 5 over 2, comma, negative 1. Let me see. Negative 1 and 5 over 2 is the option C. The order, no? 2 solutions. Okay, entonces no always is easier. Sometimes we have completely crazy, disorganized equation. And when you have fraction, immediately you remove the fraction. Don't hesitate to remove any stupid fraction. Okay? And okay, the time is over, no? No? Or you want to continue with me?
Oh, Professor.
No, it's no, too much. Okay. Don't worry, be happy. We're doing well today, super good. Now, almost we finish the 17, 18 next time, and we go to the guys. We almost finished this subject, and you are doing well. No, all the students. The majority of you are doing well. Okay, I have excellent students, but I have a student that not excellent. Okay, guys, see you.